Hello, this is Panya from SIT225, and today I'll be presenting my project for task 9.1. And this project will be called Smart Indoor Safety and Comfort Monitor. So this project will demonstrate how a simple IoT system can monitor both comfort and safety condition of indoor using multiple sensors. As for this case, I have used two sensors. So the indoor environment have a big impact on the human health, comfort, and safety. Like for example, high humidity could lead to mold growth, and it can worsen the respiratory illness, like it block, and the obstructed pathway, like it could cause accident, like tripping over an object. And the goal for this task is to try to design a prototype or give the idea of a low-cost multi-sensor IoT system that can monitor both domain of comfort and safety in real time. So in the existing method from the literature that we have above is that according to WHO in 2009, they have said that humidity level of 70 to 80% would cause an increase in mold growth risk. And the temperature count for the sensor placement of the error and accuracy matters because the radiation can cause the sensor to have an error or like an inaccurate reading. And so like how they deal with this is they can put a radiation cover on the sensor so that it will detect a more accurate reading. As for the safety, the ultrasonic sensor is widely used in robotics for like obstacle detection, and also using it so that the robot knows to avoid the obstacle based on the distance between the robot or between the ultrasonic sensors and the obstacle. However, most existing IoT projects only focus on comfort, like temperature, humidity, and CO2 levels, and the robotics project are for like safety monitoring, only focus on safety, whereas like there is very few that integrate both together at a low cost. So my proposed method would be that my system combine both the DHT22 sensors, the HCSO4 distant ultrasonic sensors connected to the Arduino Nano 30 IoT as a controller. And then the data is then collected using the Arduino sketch, then logged into a CSV file using Python script, and afterward it used pandas and matplot library to visualize the data with graph. So this is the system architecture that I have built or like I have made. So this diagram shows how the system works and the sensors, like how the sensors capture environmental and distance data, which the Arduino first process. Like first the two sensors up here would collect the data, and it would capture the data, and then it would send it to the Arduino. After that, the reading are sent to the Python logger, which is the local Python script, and which stores them locally in a CSV file. And from there, I used JupyterLab to analyze the data and produce graph for interpretation and analysis. Next is the data capture and storage. See, the Arduino in terms of workflow, the Arduino is programmed to collect the sensor reading every 2 seconds, and the data type that it's collected is the temperature in Celsius, humidity in percentage, and ultrasonic distance in centimeters. And so the Arduino output these readings through serial communication, and the Python script captures the output filters and the valid line. As you can see here, the Python script captures these data, and then it writes them into a CSV file in real time, and this allows us to later analyze and visualizes the graphs. So thank you for watching the video presentation.